Hi PU2 2026 aspirants, so your midterms are ahead, and in today's video we are going to solve the 2, 3 and numerical questions from the chapter solutions. Okay, so we have already completed one short revision of this chapter, 1 markers are done, and lastly we will be doing 2 plus 3 and numerical questions so that your entire chapter is now revised. Okay, so let's go to the first blueprint. So if you know from this chapter, you may get 1 2-marker theory, 1 2-marker question, 1 3-marker question, and you will get 2 numericals. Okay, so if I have the first question, which of the 2 molarity or molality does vary with temperature and how? Very simple, we know that molarity will vary with temperature because it has volume in its formula, and molality remains constant since it does not depend on temperature. Okay, and the second part, how? For that, what you have to write? You have to write that when temperature increases, volume increases, molarity decreases. Okay, this you have to mention at the second point. So this is 1 mark and this is 1 mark. Okay, moving to the next question, mention the factors on which the solubility depends. Very important question. Nature of the solute, nature of the solvent, pressure and temperature. Just a minute. Moving to the third question here, what is saturated solution, unsaturated solution, and the effect of temperature on the solubility of solid in liquid. Okay, so saturated solution means where you cannot dissolve any more solute, unsaturated solution where some more solute can be dissolved, and the factor, so here the solubility of solid in liquid, this process can be either endothermic or exothermic. Okay, so if it is endothermic, then with increase of temperature the solubility will increase, and if it is exothermic, with increase in temperature the solubility will decrease. Okay, clear? Next, state Henry's law, mathematical form and the importance of KH value. So the Henry's law states that at constant temperature the solubility of a gas in a liquid is directly proportional to the partial pressure of the gas present above the solution. So please remember definition, you have to remember exactly how it is written in the book. The law, please don't change the words, write it as it is in the book. And the formula P is equal to KH into X. Here you have to also define the terms where P is the partial pressure of the gas, partial pressure, KH is nothing but Henry's constant, and then X gas is equal to mole fraction of solute, mole fraction of the gas, sorry. Right, and what is the significance of KH value? Higher will be the KH value, lesser will be the solubility. Next, moving to fifth question, 2 applications of Henry's law. You know, in the beverages it is used, and in the scuba divers, in their tank, helium gas is added because it has less solubility. Moving to the next question, Raoult's law and its mathematical form. So Raoult's law states that in a solution, for a solution, the partial vapor pressure of each volatile component in the solution is directly proportional to mole fraction. So what will be the formula? So PA is proportional to XA, which can be written as P naught A XA. So I can write here, I can write PA is equal to P naught A XA, and then you have PB proportional to XB, so which is equal to, again PB is equal to P naught B into XB. Okay, and then we have total pressure, that is P total is equal to P naught A XA plus P naught B XB. Okay, now coming to the next question, state Raoult's law as compared to the binary solution of non-volatile solute in a volatile solvent. This is very important question, or I can say a tricky question actually. So if you see, if you have 2 components, okay, if you have 2 components, you have added A and B. Right, now A will create vapor, B will create vapor, so we will get here PA and PB, and the total pressure is PA plus PB. But now what happens, they are telling you that you have added a non-volatile solute. So that means what? This B which you have added, this B is non-volatile. Okay, now if this is non-volatile, then what will happen? B will not create vapor, right? B will not create vapor. So here the total pressure will again be equal to PA. Okay, P total will be equal to PA, which is equal to again P naught A XA according to the Raoult's law. Okay, so that we have to write here. When the solute is non-volatile, only the solvent molecules are present in the vapor phase and contribute to the vapor pressure. So let P1 be the vapor pressure of the solvent, X1 be its mole fraction, P01 be the vapor pressure in the pure state. Then according to Raoult's law, P1 is proportional to X1, or P1 is equal to X1 dot P01. Okay. Eighth question, write the mathematical relation between the molality and the depression in freezing point. Why is sodium chloride used to clear the snow on roads? So we know that when we add any non-volatile solute to the solvent, its freezing point decreases, right? So the water cannot remain in the solid state at that temperature because the freezing point has now decreased, so it now melts and then the road is getting cleared. So that is why we add this one, and the mathematical formula here is delta TF is equal to KF into M. So here it is there, delta TF is the depression, KF is the molar depression constant, M is molality. And why do we add sodium chloride? It lowers the freezing point of water. When spread on the snow, it causes the ice to melt even below 0 degrees Celsius, okay, now which helps in clearing and preventing the icy roads. Ninth question, you have to give reasons. Cutting onions taken from the fridge is more comfortable than cutting onions lying at room temperature. I would rather do that. So why you have to give reason for this. Next, when fruits and vegetables have dried are placed in a water, they slowly swell and turn to the original form. So first of all, what happens, you know, when we cut onion, actually it releases certain gas, okay, which creates irritation in the eyes, as a result of which we get tears. Now when you have taken this onion at a cold temperature, means when it is in the refrigerator, and then when you take it out, the escape of gas is very less, okay, because the gases have now less energy, the less kinetic energy, so they do not escape more, so the irritation in the eyes is less and we do not get tears easily, okay, that is the reason. Second one here, when fruits and vegetables are dried and are placed in water, so there is endosmosis, water flows inside it, osmosis takes place and the fruits regain their shape, okay. So let's see here. Onions from the freeze release less volatile irritating gas, so cutting them is more comfortable, and dried fruits and vegetables absorb water by endosmosis, swell and regain their original shape. Next, draw a graph to show the variation of vapor pressure of solvent and solution with respect to temperature. So this graph we have, this is the solvent solution graph that we have to draw. You know, always the solution vapor pressure will be less than the vapor pressure of the solvent, okay. 10th question, 11th question, write the expression to relate the cryoscopic constant and the change in enthalpy of fusion. Explain the terms involved in it. So Kf is equal to RTF square M divided by 1000 into delta H of fusion, and here we have Kf is your cryoscopic constant, R is the universal gas constant, Tf is the freezing point of pure solvent, M is the molar mass of the solvent, and delta H is the enthalpy of fusion. Now here you should know that we also have a similar formula of Kb, which is R Tb square M divided by 1000 into delta H vaporization, okay. So here delta H vap is enthalpy of vaporization. Next, 3-marker question. Now we will note difference between ideal and non-ideal solution, a very possible and like must do question. So obeys Raoult's law, does not obeys Raoult's law. Delta H mix equal to 0, not equal to 0. V mix equal to 0, not equal to 0. AB interactions are equal to AA-BB interactions. Here it is not equal. Example, definitely you should write N-hexane, N-heptane, bromoethane, chloroethane, benzene, toluene. And here we have ethanol, acetone, carbon disulfide and acetone, phenol and anilyl, chloroform and acetone. So there are so many examples you have to write down. Next, differentiate between the types of non-ideal solutions. So we know types of non-ideal solution are positive deviation and negative deviation. In positive deviation, the total pressure is greater than the Raoult's law and the total pressure is less than Raoult's law in negative deviation. Here it is positive deviation, means more vaporization takes place, right? Pressure is created more. So the AB interactions are weaker than AA-BB interactions. Here it is stronger. Here delta H mix is greater than 0, V mix is greater than 0. This side it is less than 0. Examples: ethanol and acetone, CS2 and acetone. Here phenol, aniline, chloroform and acetone. And you can also be knowing their graphs. This can also be asked. In positive deviation, the slope will be towards the top. In negative deviation, the slope will be towards the end below. Next, azeotrope and the mixture of difference between them. So azeotrope, how will you define it? These are the binary mixtures having the same composition in the liquid and in the vapor phase and boils at a constant temperature. Two types of azeotropes we have, maximum and minimum, right? So maximum boiling azeotrope is shown by negative deviation, minimum is shown by positive deviation. They boil at a temperature higher than the boiling point of each component. They boil at a temperature lower than the boiling point of each component. Examples. Okay. Next, fourth question. Write 3 reasons to justify that osmotic pressure is used to calculate the molar mass of the big macromolecules. So the first reason here is it gives appreciable values even for higher molar masses. So the correct values we get, it can be measured at room temperature. That is the most important thing. It provides greater accuracy than other colligative property method. Okay, any 3 points you can write here. Next, explain the desalination of water by reverse osmosis. Name the semi-permeable membrane used in this. So desalination of water by reverse osmosis. So if you know what is osmosis, so if I have two sides, okay, here it is less concentrated, here it is more concentrated, here it is less concentrated. So what will happen? Water will flow in this direction till the level of water in both the case becomes equal. So the pressure that is required here to stop this osmosis is called as osmotic pressure. But if you apply pressure greater than osmotic pressure, what will happen? The water will start flowing in opposite direction. Okay, when the water will start flowing in opposite direction, that is called as reverse osmosis. So what is its use? It is used in the desalination of water. So reverse osmosis is used in the desalination of water when pressure more than the osmotic pressure, around 30 atm, is applied to the seawater. Pure water is squeezed out of the seawater through the semi-permeable membrane. We have a diagram also to represent this. You can see here we have fresh water here, salt water here. When you give pressure more than osmotic pressure on this side, the pure water from the salt water will be going here, this side, okay, and it is collected here. Clear? So, and which type of membrane is used here? Cellulose acetate is used. Fine. Now we will go to the next section, that is numericals. So almost I will not be solving each and every numerical. I just tell you the formula. You have allowed calculator is used in the PU2 examination, so you have to calculate it and do the questions. Okay. So first question: 450 centimeter cube of an aqueous solution of a protein contains 1 gram of protein. The osmotic pressure of at 310 Kelvin is 3 into 10 to the power of minus 4 bar. Calculate the molar mass. So first let us write down how to proceed with the question. I'll tell you, you should always write the given values first. Okay. So what is the volume of the solution? Volume of the solution is 450 centimeter cube. Next we have 1 gram of protein. What is the mass of protein? Mass of protein we have is 1 gram, right? Okay. Next we have osmotic pressure. Temperature is there. Temperature is how much? 310 Kelvin. Then we have osmotic pressure, which is equal to 3.1 into 10 to the power of minus 4 bar. Okay. Now we have to calculate the molar mass of the protein. R value is already given to you, 0.083 liter bar mole inverse Kelvin inverse. Okay. So now here if I write pi is equal to C into R into T. What is C? Given mass by molar mass into 1000 by volume in ml. Okay. Then I have into R into T. So what is W here? 1 gram. So let me just substitute the values properly. So what I will get here? Pi is 3.1 into 10 to the power of minus 4. Okay, W is equal to how much? W is 1 gram. Molar mass we have to calculate 1000. Volume is 450 into 0.083 into 3110. Okay, so you have to calculate this M here by solving this one. Substitution I have done. So this will give you 1,84,444 gram per mole. Okay. Next question, 1 gram of a non-electrolyte solute is dissolved in 50 gram of benzene lowered the freezing point by 0.4 Kelvin. The freezing point depression constant is 5.12 Kelvin kilogram mole inverse. The molar mass of the solute is. Okay, same process. Let's write the given value first. So what are the given values? You have mass of the solute. So what is the mass of the solute? That is equal to 1 gram, right? Next we have mass of the solvent. So mass of the solvent or benzene is how much? 50 grams. Next we have depression in freezing point. Delta TF is given to me as 0.4 Kelvin. Next, the freezing point depression constant Kf is equal to 5.12 Kelvin kilogram mole inverse. Molar mass of the solute is how much? Okay, now let's solve this. Delta TF is equal to Kf into M. Okay, or can be written as Kf into given mass by molar mass into 1000 by mass of the solvent. Okay, so what is delta TF? 0.4. Kf value is 5.12. Okay, into W is how much? W is 1 gram. Molar mass we have to find out into 1000 by mass of the solvent is 50. Okay, now if I solve this, I can calculate the value of M, and that will be equal to 256 gram per mole. Okay, now moving to third question. On dissolving 3.46 gram of non-volatile solute in 100 gram of water, the boiling point of the solution is raised to 0.12 Kelvin. Calculate the molar mass of the non-volatile solute. Okay, Kb for water is also given. The same thing, first you have to write the given value. Okay, what is the given value here? We have first been given with the mass of the solute. Mass of solute, which is equal to 3.46 gram per mole. Next we have 100 gram of water, that is mass of water, 100 grams, or mass of the solvent. Then delta TB is equal to 0.12 Kelvin. Okay, and then calculate the molar mass of the non-volatile solute. So molar mass of the non-volatile solute we have to calculate. Delta TB is equal to Kb into M is equal to Kb into given mass by molar mass into 1000 by mass of solvent in kg. Okay, so now that will be given to me as 0.12 into Kb will be equal to how much? 0.51. Okay, into given mass is 3.46. Okay, and molar mass we have to calculate into 1000 by mass of the solvent is 100 grams. Okay, now if I solve this, we'll get the value of M, which is 147.05 gram per mole. Okay, fourth question, 31 gram of an unknown molecular material is dissolved in 500 gram of water. The resulting solution freezes at 271.14 Kelvin. Calculate the molar mass of the material Kf of water is given, T naught of F is given. Again freezing point question. So I'll just write down the given values first. What are the given values here? Mass of the solute is how much? Mass of solute is 31 grams, right? Then mass of solvent. Mass of solvent is 500 grams, okay? Then TF, freezing point of the solution, is 271.14 Kelvin. Freezing point of the solution, a solvent, the original freezing point is 273 Kelvin. Kf value is 1.86 Kelvin kilogram mole inverse. Okay, so now we have this formula, delta TF is equal to Kf into M. Delta TF is what? TF minus T naught F, sorry, we will have a value like this, T naught F minus TF is equal to Kf into W by M into 1000 by mass of solvent. Okay, now here if I have 273 minus 271.14, that is equal to Kf 1.86 into W is 31 by M into 1000 by 500. Okay, now if I solve this, I'll get the value of M here. So what will be the value? 62 gram per mole. Okay, moving to the fifth question. Vapor pressure of benzene is 200 mm of Hg. When 2 gram of non-volatile solute is dissolved in 78 gram of benzene, benzene has a vapor pressure of 195 mm of Sg. Calculate the molar mass of the solute. Molar mass of benzene is given to us. So yes, let us first find out the vapor pressure of benzene is how much. That is given to me as 200 mm of Hg. Right. Next, what is there? When 2 gram of non-volatile solute is added. So what is the mass of the solute? Mass of solute is 2 gram. Dissolved in 78 gram of benzene. So here I have mass of solvent 78 gram of benzene. Benzene has a vapor pressure of P of benzene. Okay, benzene has a vapor pressure of 195 mm Hg. Okay, calculate the molar mass of the solute. You have to calculate the molar mass. Molar mass of solute. Molar mass of benzene we already know, that is molar mass of benzene, which is equal to 78 gram per mole. Okay, so now let us calculate it. So we know that, see, what is the formula? P naught minus P by P naught is equal to XB, which is equal to NB by NA plus NB, but in dilute solution we can ignore this NA, right? So now if I write what is the value of P naught, that is 200, okay, minus 195, okay, divided by 200 is equal to number of moles of B or number of moles of solute, that is 2 divided by molar mass, and number of moles of benzene is 78 by 78, right, that is 1. So now you can also so that is the thing. Now we can solve it. So if I solve it, 5 by 200, so I'll get here 5 by 200, okay, equal to let me just substitute here this one. 1 second. First let me calculate with this how much I'm getting. 5 by 200 will be 2 by molar mass. So if I just calculate here, so it will give me 80 grams per mole. Okay, 80 gram we will get which is the correct answer. You can ignore this NB in this type of questions, not everywhere but in this type of questions. The boiling point of benzene is 353.23 when 1.80 gram of non-volatile solute was dissolved in 90 gram of benzene. The boiling point was raised to this one. Calculate the molar mass of the solute. Again similar question from boiling point. So now I will be directly just putting the values, will not be writing everything, but in the exam you will have to do the complete solution. Okay. So what is formula? TB minus T0B equal to Kb into M, which is equal to given mass by molar mass into 1000 by mass of solvent. Okay. So now if I solve this, what is the final boiling point? 354.11 minus 353.23. Okay, that is equal to Kb is 2.53 and then mass of the solute is 1.8 grams. Okay, molar mass we have to find out, 1000 by mass of the solvent is 90 grams. So now if I solve this, the M value that I'll get is 57.27 gram per mole. Okay. Let's see the next question here. 5.8 gram of non-volatile solute was dissolved in 100 gram of carbon disulfide. The vapor pressure of the solution was found to be 190 mm of Sg. Calculate the molecular mass of the solute. Vapor pressure of the pure carbon disulfide is this much. Okay, so let us write down the value here. What is the mass of solvent? Sorry, given is what? Given, if I just note down the given value, mass of solute. Okay, mass of solute is 5.8 grams. Dissolved in 100 gram of carbon disulfide. So mass of solvent is 100 grams, right? The vapor pressure of the solution was found to be 190 mm of Sg. Vapor pressure of solution is how much? 190 mm Hg. Okay. Next we have calculated the molecular mass of the solute. The vapor pressure of pure carbon disulfide is 195 mm of Hg. Okay, and then calculate the molecular mass of the solute. Molecular mass of solute. Okay, molecular mass of the solute is 76 gram per mole. Okay, and we have here molar mass of the solute we have to find out. That is what we have to find out. Okay, now if I just try to substitute this one, what will be the formula we have? P0 minus P by P0 is equal to XB, which is equal to NB by NA, right? So what is the value of P0 here? P0 is 195 minus 190 by 195, that is equal to number of moles of B, 5.8 by molar mass into Na, that is molecular mass of the solvent is 100 grams divided by the molecular mass, which is 76 gram per mole. Okay, so now if I solve this and find the value of M, that will give me 171.91 gram per mole. Please check the calculation and let me know in the comment section if you have any problem in any question. Okay, moving to the 8th question. 1 gram of non-electrolyte solute is dissolved in 50 gram of benzene. Lowered the freezing point of benzene by 0.4 Kelvin. Find the molar mass of the solute. Okay, so again if I note down the given values. Okay, so I have here mass of the solute, right? First one is mass of solute, which is equal to 1 gram. Next, dissolved in 50 gram of benzene. Mass of solvent is how much? 50 gram of benzene. Lowered the freezing point by 0.4 Kelvin. Delta TF is equal to 0.4 Kelvin. Find the molar mass of the solute. Kf value is 5.12 Kelvin kilogram mole inverse. Okay, now let's solve this. Delta TF is equal to KF into M. Now what is delta TF value? 0.4. KF value is 5.12. M value is 1 gram by molar mass into 1000 by this one is 50. Now if I solve this M value will be 256 gram per mole. Okay. Next, this last question is there of today's lecture. The vapor pressure of pure benzene at a certain temperature is 0.85 bar. A non-volatile solute weighing 0.5 gram when added to 39 gram of benzene, the vapor pressure of the solute is 0.845 bar. Now, what is the molar mass of the solid substance? So, I want all of you to try this question by your own, okay? Try this question by your own, okay? And then comment the answers of this question in the comment section, and then I'll tell you whether you have got the correct answer or not. Okay, so that is here, that is something. Yes, now I'll tell you the most important topics that you must revise from this chapter: Henry's law, Raoult's law, first of all, colligative properties, and about ideal and non-ideal solutions. Okay, so all the examples, graphs, positive deviation, negative deviation, azeotrops, everything you have to study. Okay, so revise these topics, then definitely you are ready to get, just a minute. Yeah, so with this you will be ready to get 70 out of 70 in the midterm chapter solutions. Okay, so overall this is all about this particular chapter. If you have any further doubt, please put down in the comment section, I'll take it. And thank you for watching. All the best, and please follow this midterm series, you will definitely be benefited. Okay, that's all.